Imagine waking up to a sky dominated by the giant blue planet Uranus. Suddenly, our familiar blue sky is overshadowed by an immense icy giant. This isn't just any ordinary day, it's the beginning of a cosmic catastrophe. Let's unpack this hypothetical scenario. Uranus, a colossal planet made mostly of hydrogen, helium, and water, is on a direct collision course with Earth. To put things into perspective, Uranus is about 4 times the diameter of Earth and carries a mass that is 14 times greater. Its arrival disrupts our planet's regular rhythm. As Uranus draws closer, the gravitational effects become alarmingly evident. Our oceans would bulge out towards the intruder, tides would surge beyond their usual limits, and the very crust of the Earth would groan under the astronomic strain. This isn't just a meeting of 2 celestial bodies, it's a dance of destruction where the music speeds up as the finale approaches. Now hold that thought as we dive deeper into the gravitational dance that spells doom. As Uranus approaches, the first messenger of chaos would be gravity. This fundamental force, which keeps our feet firmly planted on Earth, would become a harbinger of destruction in the face of such an immense celestial event. Gravity, as we understand it, is the force that attracts 2 bodies towards each other. Everything with mass exerts a gravitational pull, from the smallest pebble to the largest star in the galaxy. Uranus, being about 14.5 times the mass of Earth, has a gravitational pull strong enough to wreak havoc from millions of miles away. Imagine Uranus inching closer to our planet. Its colossal gravitational field would start influencing Earth long before the 2 giants even come close to touching. One of the first phenomena we would observe is the intensification of tidal forces. Our oceans, always in silent conversation with the moon through the ebb and flow of tides, would now whisper to a much larger listener. These new tidal forces could lead to unprecedented tidal surges, dramatically reshaping coastlines and flooding cities. But the effects of Uranus's approach wouldn't be limited to our seas. The gravitational tug could alter Earth's orbit slightly, affecting the length of our year. It might even influence the Earth's rotation, leading to longer days or nights, confusing the natural rhythms that dictate the behavior of wildlife and our own biological clocks. Furthermore, the immense gravitational pull could start to affect the tectonic plates beneath Earth's crust. The stress and strain on these plates might lead to increased volcanic activity and earthquakes, events that could alter the very surface of our planet. Mountain ranges could rise anew, islands could sink back into the ocean depths. With these titanic forces at play, Earth's very landscape begins to warp. As we ponder the approach of Uranus, it becomes clear that the dance of gravity is not always a gentle waltz, but can also be a powerful force capable of reshaping worlds. With our orbit disrupted, Earth's climate starts dancing to a terrifying new tune. The gravitational disturbances caused by the approach of Uranus unleash a symphony of environmental chaos. Imagine the jet streams, those high-altitude air currents that guide our weather, now twisting and turning in unpredictable ways. This alteration leads to extreme weather patterns that our current models can barely anticipate. As these jet streams shift, regions that once enjoyed mild and stable weather could face violent storms and unprecedented heat waves. Conversely, areas accustomed to regular rainfall might suddenly find themselves grappling with drought. The ripple effects of these changes disrupt agricultural cycles, threaten food security, and increase the frequency of natural disasters. The changes don't stop at the weather. The gravitational pull of Uranus, now disturbing Earth's own gravitational balance, could cause significant alterations in sea levels. Imagine the oceans, no longer held in their usual confines, swelling and shrinking in new, dangerous patterns. Coastal cities worldwide face the risk of being submerged under sudden tidal surges or exposed by unexpected drops in sea levels. Moreover, the atmospheric composition begins to warp. With increased volcanic activity and shifting tectonic plates, vast amounts of carbon dioxide and methane could be released into the atmosphere, accelerating the greenhouse effect and leading to even more drastic temperature swings. And as if weather gone wild was not enough, the final act is yet to commence. Now, as Uranus looms larger, the sky darkens under its immense shadow. Picture this, a giant icy behemoth, 17 times the mass of Earth, drawing perilously close. As it approaches, the gravitational force it exerts grows exponentially, pulling at the very fabric of our planet. The seas begin to roar more fiercely, whipped into a frenzy by the increasing gravitational pull. Tides rise to unprecedented heights, causing widespread flooding in coastal cities. The once predictable ebb and flow of the ocean now seemed to dance chaotically, dictated by the whims of this approaching giant. Inland, the story isn't much better. The intense gravitational forces start to wreak havoc on the Earth's crust. Volcanoes dormant for centuries awaken in a symphony of eruptions. The ground shakes with increasing frequency and intensity as earthquakes ripple across the globe. Each tremor is a stark reminder of the powerful forces at play as Uranus draws nearer. Above, the atmosphere stretches and thins. The outer layers exposed to the vacuum of space begin to strip away, pulled towards the new massive neighbor in our solar system. This loss leads to dramatic changes in our air composition and pressure, making it increasingly difficult for life as we know it to sustain itself. Skies that were once a familiar blue now turn a haunting shade of gray, filled with the debris of volcanic ashes and the chilling winds that sweep across continents. Temperatures plummet as the shadow of Uranus blocks out the sun's rays, casting large parts of the Earth into a premature and eerie twilight. Regions that once basked in warmth now shiver, as the cold grip of space makes its presence felt. The environmental shift is rapid and ruthless, leaving ecosystems struggling to adapt to the new harsh conditions. In these last moments, Earth is a planet transformed, bracing for impact. The moment of impact, a spectacle of cosmic proportions. Imagine the sheer scale of this event. Uranus, a giant ice planet, collides with Earth. The initial contact would trigger an explosion beyond any human comprehension, releasing energy comparable to billions of nuclear bombs, detonating simultaneously. This catastrophic release of energy would produce shockwaves that radiate outwards through both planets. At the point of impact, the temperatures would skyrocket, vaporizing huge swaths of the Earth's crust and Uranus's icy exterior almost instantly. The force exerted would be so immense that it would likely split the Earth into fragments, sending some hurtling into space while others would remain, molten and chaotic. Following the immediate explosion, the aftermath on Earth would be apocalyptic. The collision would throw up into the sky a thick cloud of debris, consisting of rock, ice, and vaporized material. This debris cloud would envelop our planet, blocking out the sun and plunging the world into darkness, a period that could be termed an impact winter. Temperatures would drop drastically as sunlight fails to penetrate this dense, swirling canopy of dust and ash, but the effects wouldn't be confined to Earth alone. The force of the impact would eject a significant amount of debris from both Earth and Uranus into space. Some of this debris would enter orbit around the Sun, potentially forming a new, albeit temporary, ring of celestial material. This ring, composed of ice, rock, and remnants of both planets, would serve as a stark reminder of the collision's ferocity. As Earth reels from the initial impact, global firestorms would likely ignite. These are not your ordinary wildfires. These would be massive conflagrations fueled by debris and superheated gases capable of burning vast areas of the planet. The atmosphere itself would become a hostile environment filled with toxic gases and particulate matter, rendering it inhospitable for any form of life as we know it. In the oceans, the shock waves would generate colossal tsunamis, traveling at high speeds and reshaping coastlines. Marine ecosystems, already stressed by changes in temperature and light, would face immediate and severe consequences, likely leading to mass extinctions. In the wake of this cataclysm, Earth as we know it ceases to exist. The planet that emerges from the aftermath of this colossal impact would be unrecognizable, a barren, chaotic landscape shrouded in darkness and silence, a stark witness to the cosmic forces that shape our universe. While this scenario is purely hypothetical, it underscores a profound truth. Throughout this exploration, we've ventured through the cosmic dance of gravitational forces, witnessing firsthand the chaos a celestial giant like Uranus could unleash upon Earth. From gravitational turbulence stirring our planet's very core, to climatic havoc disrupting our weather systems, the journey has been nothing short of dramatic. Reflecting on these points, it becomes clear just how pivotal gravitational forces are within our universe. They hold the power not only to create but also to destroy. This understanding brings to light the intricate celestial mechanics that govern our solar system, revealing the delicate balance that sustains life on Earth. Moreover, this thought experiment highlights our planet's vulnerabilities. It serves as a reminder of the importance of space science and why we must continue to study the cosmos with keen eyes. Though the chances are astronomically low, the collision between Earth and Uranus reminds us of our place in the cosmos, a tiny speck in the vast dance of the universe.